Hello, and welcome to the 2024 Design Expo. My name is Drew Barish, and I, along with other members of the Robotic Systems Enterprise, will be discussing our work towards the 4-year autonomous vehicle competition hosted by General Motors and SAE, known as AutoDrive.
Robotic Systems Enterprise is made up of 7 teams, including perception, mapping and planning, simulation, controls, build, innovation congestion, and innovation accessibility.
In the perception team, we use the computer vision model YOLO-V5 for detecting traffic signs. The process looks like this. We fed the frames obtained from the camera into the YOLO-V5 model. After this, we obtain bounding boxes for the objects. We then use OpenCV to detect the states of the signs. Finally, these objects detected then get fused with the objects detected by the LiDAR. One of the issues faced with the use of convolutional neural network is the need to acquire training data. In order to deal with this problem, we needed to extract images from Verbrugge and come up with a solution to avoid repeated images.
One challenge we needed to overcome when training our neural network was avoiding lots of near-identical images that might simply be shifted or tilted compared to one another. The program we built to solve this creates reduced thumbnails for each of our images, calculates the total difference between those thumbnails, and uses that to quantify how distinct they are from one another.
The mapping and path planning subteam implements features to handle spatial awareness in line with the AutoDrive intersection and highway challenges. Supplied geopackage data was modified to translate center points into usable lat and long points in lane regions on the competition map. From this, scripts were developed to generate a large CSV file that represented the costs between each point. These connections were then adapted to incorporate directional and region-based information to utilize as inputs for the vehicle's integrated path planner and situational controller.
On the simulation team, we work to complete challenges that MathWorks present to us each year, and in the past, that has included validating the sensor placement on the vehicle to determine that we have the best configuration, as well as simulating an unprotected left turn scenario as you see here. You're currently watching a Roadrunner scenario carry out our unprotected left turn scenario, using behaviors that we have defined such as stopping at the stop line and adhering to traffic lights. We are currently working on getting a testing server set up and using MathWorks products such as MATLAB, Simulink, and Roadrunner in order to output simulated camera and LiDAR data from our simulated model of our Chevy Bolt for the rest of our teams to use to test their systems.
We utilize this Python program to create the path for the car to follow. We can input commands like this with parameters for distance and radii and export the waypoints as a G-code file.
The HMI device allows the car to switch in and out of autonomous mode.
This is the inside view of the vehicle from when we were testing. As you can see, we have a safety driver in place and are using a couple laptops to monitor the various high-speed CAN messages coming from the vehicle.
This is the blinkers being controlled by the car Simulink by sending CAN messages through the DSpace controller.
Hi, I'm Tabitha, and I'm the project manager for Build Team.
Hi, I'm Philip. I'm one of the many members of Build Team. We'll be talking about what we did this semester.
Here is the final CAD model we came up with last semester that we used as a base reference for the designs for this semester.
The ideas we came off of the base are design A, B, C, and D when it comes to supporting it laterally. We went through all kinds of testing, and from there we went with design B.
So this is the final CAD design we came up with, implementing the design B support along with the shroud, and we are currently working on construction, which Phil will talk about next.
The construction is almost done. We need to do some welding at this very moment, but from there everything has been drilled, tapped, cut, and put together. From here we'll be working on implementation, testing, and mounting.
In the bustling world of autonomous vehicle innovation, one team stands out with its groundbreaking approach to tackling road congestion, the Innovation Congestion Team from Prometheus Borealis. As part of this year's Electrifying AutoDrive 2 challenge, they've taken a deep dive into the pervasive issue of traffic congestion, an ordeal every driver dreads. At the core of their mission, the team focused on identifying a specific congestion symptom that could be alleviated using the unique capabilities of autonomous vehicles. Their journey led them to conduct comprehensive design trade-off studies, laying the groundwork for a solution that's as intelligent as it is intuitive. Their efforts culminated in the creation of a sophisticated software called Route, demonstrating how their innovation integrates seamlessly with their autonomous vehicle to combat congestion. But what sets the innovation congestion team apart? It's their commitment to understanding the far-reaching impacts of vehicle congestion, not just on the road, but on society at large. They delved into the major implications of traffic jams, presenting compelling evidence on how their solution, Route, responsive optimization utility for traffic efficiency, can make a substantial difference. Route isn't just software, it's a visionary approach to traffic management. By harnessing the power of V2X communication, assessing your vehicle's state of charge, and even integrating your personal calendar, Route crafts an optimal journey that sidesteps traffic snarls. Imagine reorganizing your day to bypass congestion or enabling businesses and universities to stagger start times, all in a bid to smooth out traffic flow.
Hi everyone, my name is Olivia and I am the team lead for the AutoDrive Innovation Accessibility team. Our team also consists of Nick Johnson, our project manager, along with Holden Sutherland and Nick Webster. Our team is tasked with creating a solution to improve accessibility in autonomous vehicles. This year, we are developing Stewie, which implements a steward platform as a seat to combat forces experienced due to vehicle movement. In order to develop Stewie, we gathered data from our target audience. This includes individuals with limited mobility and those who frequently interact with these individuals. The data was collected and organized in a Google Forms survey. We reached out to 4 organizations and are continuing to gather responses. This survey was completely anonymous, but we still had to obtain training and work through the legal requirements. We will present our progress and findings at the SAE World Congress in Detroit this week. We will be bringing some of these physical demonstrations, like the Stewart platform, and seat imprints along with our final presentation. All of this work will contribute to our achievements and scores in the AutoDrive competition this summer.
Looking to the future, we have 2 main goals we aim to accomplish in our next year. One goal is to make our system capable of navigating the vehicle without GPS, relying on camera and LiDAR data instead. This requirement will be part of the AutoDrive competition next year. During testing this year, we also encountered some issues with our vehicle control code. We found that the new code we were using to control our vehicle caused an unexpected shutdown, and the exact reason has been difficult to trace. Another goal for the upcoming year is to find out what caused the shutdown and how to fix it, along with making our system overall more robust and competition ready.
On behalf of the Robotic Systems Enterprise and our AutoDrive 2 team, Prometheus Borealis, we'd like to thank our competition sponsors for all they do to support us. We'd also like to thank our advisors, Dr. Voss and Dr. Robinette, for all their support of our students. Thank you for your time, and happy Michigan Tech 2024 Design Expo.